I work exclusively with how our applicators are actually applying those chemicals and what technology they're using to make those even better and more profitable. Again, that's kind of got to be the bottom line, short term, sustainable long term. I've been on board for 3 years, and we're realizing that a lot of the issues associated with applications across the state have less to do with the chemistry that's applied and more how the chemistry is handled and how it's applied, whether it's the equipment, application variables, or pressures that each of the applicators we've talked about, the different systems are in. So that's pretty easy to fix. And so we can fix that with just education and informing people on new technology and how to treat that new technology, how to use it. And that covers the spectrum of all applications. We're not talking specifically about insects or plants, or it's anybody applying, homeowners applying. I've worked with the Christmas Tree Association or row crops, so anybody applying, the physics are the same in all of those, the social pressures are different. We've lost a lot of chemistries recently, particularly in the Delta, because of weed resistance. A lot of that has to do with overuse of those pesticides. So you overuse them too much, we develop resistance. Part of that equation is poor efficacy when they are applied, and that comes back to application error and mistakes. And so long term, if we want to have sustainable systems and the appropriate use of pesticides, the best way to do that is maintain current chemistries and treat them properly. And so that would be linked to sustainability. In the short term, the whole goal of applications is to target specific weeds, insects, pathogens, and to eliminate those when they are determined to be pests. And so we try to, with this program in the immediate, for a economical reason, help the producer to balance that drift control with coverage to get their products to work best. The pressures they're facing is narrow windows of spray times. They're hemmed in between middle of the day, early middle to late middle of the day would be ideal. Weather variables, when the ground is dry enough to spray, and so when there is a window, they have possible thousands of acres to cover, and so that window really encourages them to travel as fast as possible, to put out as little water as possible. And the reason that works is because that's less fill times, one tank goes further. And so between those two pressures, the trend is to push chemistries to their limit, both biologically and physically, of how fast can I travel, how much little water can go out, so that at the end of the day, I can cover more acres and go home at a somewhat reasonable time. And so those pressures is what we're fighting against. And what my program is trying to push back against is can we be more profitable by doing a better job as opposed to just getting it done faster? And what that entails is technology that helps still winning on both sides, but make shortcuts to those. And by slowing down, trying to change other variables in the system besides actual in-field applications where the chemistry counts. If you've got enough acres, you can financially justify and pay for a sprayer in a matter of seasons instead of paying someone else to do it. And the other side of that is you're not first in line when you call a commercial applicator. A commercial applicator has everyone calling at the same time. So those logistical issues have really pushed the trend towards them purchasing their own sprayers. And that's where the problem comes in, is that trend from expert sprayers, being professional sprayers, to purchasing really advanced technology and maybe treating it like we did 20 years ago when we did our own applications. 20 years ago, we were traveling 8 to 10 miles an hour, and the crop sensitivity to these products wasn't the same level that we're looking at today. And so between those two variables intersecting, we're really kind of at an interesting pinnacle of potential problems with these chemistries and the equipment capabilities of the producers that have the experience operating them but maybe don't understand what they're doing as often as they should. An average boom size in the Delta today, they're talking $600 to $800 for a set of nozzles. if you're not seeing the difference, then why spend the $600 to $700? So it's just an easy place they think to cut. If the equipment breaks down, that's a big deal because it doesn't operate. If a nozzle wears out, it's still operating, just not at optimal levels. And so it's pretty easy to neglect. And so, we talked about tank fill up. We talked about shaving time on clean out. We talked about, all of these system time sponges that's soaking up their time, where we can shave there that doesn't cost them on chemical efficacy. And so if we can put the time where it counts. So I'm trying to provide both the data to show that what they should be doing and also motivation for adopting technology that allows them to do that and not cost them time in the long run at the end of the day.